Okay, so good morning. Okay, so once again, very fresh good morning to one and all. Okay, in that last lecture, we have which point we have covered that point already. We have discussed what is meant by the PIT, what is meant by the poly basis system and chapter basis system. That 2 points, okay, already we have covered. And our next topic, okay, for today's lecture is geometrical dimension tolerance. Okay, geometrical tolerance we can say. Okay, what is our today's topic? The name of topic is the geometrical. Okay, geometrical dimension tolerance. Okay, geometrical tolerance we can write here. Okay, geometrical tolerances. Okay, then what is meant by the geometrical tolerances? Yes, the geometrical tolerance is nothing but it is the graphical representation of the drawing. Okay, it is the graphical representation, or it is the scientific one. Drawing language is there, we can say. Okay, just we are giving here one symbols. Okay, and with the help of the symbol we should know about the drawing. Okay, means it is the geometrical tolerance is nothing but it is the graphical representation, okay, of the symbols. Generally see here that geometrical symbol having the 5 types are there. Okay, the geometrical tolerances are classified into the 5 types. The first type is the form. Okay, first is the form. Then second it will be the location. Okay, location. The third it will be the orientation. Okay, orientation. Fourth it will be the runout. Okay, fourth it is the runout, and the 5 is the profile. Okay, these are the 5 types of geometrical tolerances. Now see, these are the 5 types of the geometrical tolerances are there, and with respect to that 5 geometrical tolerances, we are having 14 symbols are there. We are having the 14. Okay, we are having the 14 geometrical symbols are there. Okay, that 14 geometrical symbols we have to, okay, now do the study here. Okay, so what are the geometrical tolerances are there? Forma, then location, then orientation, then runout, and the profile. These are the simple types of the geometrical tolerances are there. And again, that forma, again it is classified into different types. Again it is classified. Okay, like this, there are the 14 symbols are there. Okay, for that geometrical tolerances, how many symbols are there? How many characteristics are there? Yes,
14.
Okay, 14. Like say here in that form, it having the 4 characteristics are there. Okay, in that location, again it having the 3 characteristics are there. In that orientation, it having the 3 characteristics are there. Then runout, it having the 2 characteristics are there. And the profile, it having the 2 characteristics. Then please make some it. How many are there? 4, 6. Okay, then 14. It is correct. And 14 characteristics are there. So one by one we will discuss here. Okay, so first up on the first part I will write here. The first types of the geometrical tolerance is the forma type tolerance. Okay, forma type geometrical tolerance. Forma means it is the shape line like this. Forma. Okay. Okay. Again, in this type of the geometrical tolerances, there are the 4. How many characteristics are there? 4 characteristics are there. What are these? The first is the straightness. First is the straightness. Okay, straightness. Then second is the flatness.
Flatness.
Yes, flatness. Then third is the
Circularity.
Circularity. Good.
Cylindricity.
Good. Circularity. Circularity and the cylindricity. These are the cylindricity. Cylindricity. Okay, these are the characteristics of the forma geometrical tolerances. Okay, so now we will discuss here what is meant by the straightness. Okay, when we can call it straightness, when we can call it the flatness, and when we can call it as the cylindricity and circularity. Okay, so we will discuss here with the example. For example, okay, straightness. What is meant by the straightness? Straightness means it is indicate that how much that component is straight. Means, for example, suppose we are having the pen. Okay, it is visible to all. Yes. So this is pen. Okay, just take the example. Okay, how much that pen is straight. Okay, it is called as a straightness. Means, for example, suppose we are having, suppose this is the one rod in there. Okay, suppose this is the one rod. Just a minute. Suppose this is the one rod is here. Or we can say, suppose this is the pen. Okay, just I will take the example here. Okay, we were discussing here the what is meant by the straightness. Okay, then tell me whether suppose this is the one rod. Okay, how much this line is straight, or how much this rod is straight. Okay, straightness is nothing but it is indicate that how much that component is straight. Okay, then tell me after the manufacturing, it is possible to produce exact straight part. It is possible. Sometime it will produce like this. Okay, this line. Okay, this line. Right now you are observing it is straight, but in the actual practice, it is not possible to produce a straight. Okay, some waviness will be there like this. Okay, how much it will produce like this? It will produce like this. Okay, it will produce like this. Means some waviness it will be produced. म्हणजे मला सांगा, हे जे काय कॉम्पोनंट आहे एक्झॅक्ट स्टेट मध्ये तयार होणार आहे का? एक्झॅक्ट 100% स्ट्रेट असणार आहे का? यस,
नाही.
काही तर त्याच्यामध्ये व्हॅरिएशन येणार आहेत, अप डाऊन्स असणार आहे तिथं, त्याला आपण काय म्हणतो वेव्हनेस म्हणतो, असं असेल तुमचं काम. बट दिस लाईन शुड बी लाईक दिस. आता हे लाईन तुमच्या अशी आली, वेव्हनेस आला ह्याच्यामध्ये, बट दॅट वेव्हनेस शुड हॅव द सम टॉलरन्सेस. मीन्स समजा दॅट स्ट्रेटनेस शुड हॅव 0.01 mm लाईक दिस. सपोज दे हॅव गिवन हिअर लाईक दिस. जर त्याने असं आपल्याला दिलं ह्या ठिकाणी, ओके, suppose they have given like this. So this is the symbol for the straightness. The symbol for the straightness, it is the only straight line. Okay, so this is the straightness symbol, and suppose they have written here 0.1 mm. Means what is the meaning of this? The straightness of this component. Okay, the straightness of this component should be within 0.1 mm, within 0.1 micron. Okay, म्हणजे काय पाहिजे, जर तुमची हे लाईन जर 100% स्ट्रेट नसेल, ओके, असं असेल, आणि हे जर लाईन तुमच्या टॉलरन्स मध्ये असेल, म्हणजे 0.01 mm अप डाऊन असेल, असे असेल, अगेन इट इज acceptable. It is called as the straightness. So understood? Straightness is nothing but it is showing the how much that component is straight. Okay, see this is straight. Okay, but in actual practice it's showing the some heaviness. म्हणजे हा पार्ट आहे, एक पेन आहे, हा पेन कम्प्लिटली स्ट्रेट मला पाहिजे, पण इट इज पॉसिबल टू प्रोड्यूस द स्ट्रेट? नो. म्हणून मी काय करतो, टॉलरन्स देतो स्ट्रेटनेसचा. किती टॉलरन्स दिला? फॉर एक्झाम्पल 1 mm. ओके, 1 mm असेल. जर ही लाईन 1 mm अप गेली आणि 1 mm डाऊन आली, म्हणजे ह्याच्या मिडलला जर अशी तयार झाली, अगेन आय विल ऍक्सेप्ट इट इज स्ट्रेट. ओके, सो इट इज स्ट्रेट. सो अंडरस्टूड? Okay, then the next is the flatness. Then what is meant by the flatness? Again, it will show the information regarding to the how much that component is the flat. How much that component is the flat means what? Okay, suppose for example we are having one box. Suppose this is the one component in there. Suppose this is the one component. Okay, for example, take example of the, suppose this is the say this is the mobile. Okay, and we have to see the surface of that mobile, it should be flat. The surface of that mobile, it should be flat. म्हणजे हा काय एक कॉम्पोनंट आहे, आणि ह्याचा सरफेस मला कसा पाहिजे, 100% फ्लॅट पाहिजे. ओके, पण मला सांगा, जर मी ह्याचा सरफेस फ्लॅटनेस चेक केला, ओके, सपोज आय हॅव चेक द फ्लॅटनेस ऑफ दॅट कॉम्पोनंट ऑन द फोर्थ what we can say, all the direction, we can say on all the direction. ओके, तर मला सांगा 100% असं असेल का? हे जे कॉम्पोनंट आहे ते थ्रूआउट फ्लॅट असणार आहे का नाही? काय तर ह्याच्यामध्ये व्हेरिएशन्स असणार आहेत लाईक दिस, ह्याच्यामध्ये काय तर व्हेरिएशन्स असणार आहेत. बरोबर आहे का? बरोबर आहे का?
Yes, sir.
Okay. Okay. And that variation should be within tolerance. That variation should be within tolerance. म्हणजे समजा जर आपल्याला असं दिलं असेल, okay, suppose like this they have given. Suppose they have given like this. See, this is the symbol for the flatness. So this is the symbol for the flatness. Okay, one. Then what is the meaning of this? The flatness of that surface is required within 1 mm. Within 1 mm means what? Within n mm. म्हणजे काय? जर तुमचा फ्लॅटनेस थोडा प्लस मायनस मध्ये 1 mm जास्त कमी जास्त असेल तर आपल्याला हा ऍक्सेप्टेबल आहे. इट इज कॉल्ड एज द फ्लॅटनेस. सो अंडरस्टूड? फ्लॅटनेस मीन्स समांतर. त्याचा भाग कसा फ्लॅट आहे. इट इज कॉल्ड एज द फ्लॅटनेस. Yes, understood? Now see here, I will write down here. What is the symbol for the straightness? The symbol for the straightness is the straight line. And what is the symbol for the flatness? It will be like this. This is the symbol for the flatness. Okay. So understood? Samajhtai ka? Yes or no?
Yes, sir.
Okay. Then tell me, what is meant by the circularity? What is meant by the circularity? When we can call it is the circular part. Yes. What is meant by the circularity? What is meant by the circularity? Yes. Suppose we are having one circle. When we can call that circle is the good circularity. Suppose this is the circle. Suppose this is the circle and this is the center point. Okay. And suppose we have checked the radius in all directions. Suppose I have checked the radius of that circle in all directions. Suppose radius in this direction it is 20, then it is 20, it is 20, it is 20, and it is 20. Then we can call it is circular. Yes. Yes. Now we can call it a circular or not circular?
Circular.
It is circular now because from this center point, I have checked the radius in all direction and that radius is equally distributed. म्हणजे पूर्णपणे ह्या सर्कलची रेडियस ऑल डायरेक्शनला सेम आहे. बट इन ऍक्च्युअली इट इज नॉट पॉसिबल.
Perpendicular to common axis.
Yes.
All the points are perpendicular to the common axis.
Okay. But in the actual it is not possible. जर ऍक्च्युअल मध्ये आपण एखादं होल ड्रिल केलं किंवा एखादं काय आपलं सर्कल असेल तर कसं प्रोड्यूस होतं? लाईक दिस. इट विल प्रोड्यूस लाईक दिस. It will produce like this. Okay. And here you have to remember, okay, here they will give the tolerance like this. Here they will give the tolerance like this. Okay, see here. The symbol for the circularity, it will be showing like this. Circle and 0.01. Then tell me, what is the meaning of this? The circularity of this circle, it should be lies between 0.1. म्हणजे जर तुमचं सर्कल जर समजा हे तर 20 च्या ऐवजी किती आलं 20.1 आलं 21 आलं 20.5 आलं असं जर व्हॅल्युटी दाखवत असेल तर इट इज ऍक्सेप्टेबल. इट इज कॉल्ड एज द सर्क्युलरिटी. सो अंडरस्टूड? इट इज द सर्क्युलरिटी. समजतंय का? येस.
Yes.
Yes.
Okay, then cylindricity. What is meant by the cylindricity? When we can call it is the cylindrical surface. Yes. What is meant by the cylindricity? Suppose we are having one cylinder. Suppose this is the cylinder. Okay, in that circularity, we are checking the only one circle like this. In the circularity, we are checking this circle. Okay, this circle and the radius of that circle should be equal in all the directions. And if it is not, it should be within the tolerance. Okay, but in the cylindricity, okay, in the cylindricity, okay, suppose we have to check the cylindricity of this cylinder. Suppose this is the cylinder, we have to check the cylindricity. Then we have to check throughout this cylinder. This cylinder मधले पूर्ण सर्कल आपण चेक करायचे. Like this. Okay. Like this. Throughout cylinder we have to check. म्हणजे पूर्णपणे ह्या ठिकाणी पण हे रेडियस किती पाहिजे? According to our requirement. Like this. Okay. Like this. Then we can call it is the cylinder. Cylindricity. Understood or not? येस और नो?
Yes, sir.
ओके, म्हणजे समजा फॉर एक्झाम्पल सिलेंड्रिसिटी आहे. सपोज दिस इज द सिलेंडर. सी ए प्लेस, समजा मी ह्या ठिकाणी पण सिलेंडर सर्कल चेक केलं बी प्लसला, म्हणजे बी पॉइंटला. ओके, सपोज आय हॅव चेक द सर्कल ॲट दिस पॉइंट ऑल्सो. ओके सी. ओके, म्हणजे समजा इथून मी रेडी चेक केली ऑल द डिरेक्शन. आपल्या टॉलरन्स मध्ये आहे प्लस मायनस 0.1. अगेन इट इज प्लस मायनस 0.1 प्लस मायनस 0.1. हे जर सगळे जर ह्याची सिलेंड्रिसिटी या सगळ्या सर्कलची जर आपल्या टॉलरन्स झोन मध्ये असेल तर वी कॅन कॉल इट इज द दिस सिलेंडर इज द हॅव्हिंग गुड सिलेंड्रिसिटी. येस और नो? अंडरस्टूड? Yes or no?
Yes, sir.
Then how to show the cylindricity? How to show the cylindricity? The cylindricity, now see here, this is the symbol for the circularity and the symbol for the circular cylindricity is like this. Throughout. Okay, so understood? This is about the former geometrical tolerances. How much it is straight, how much it is flatness, how much it is circularity, and how much it is cylindricity. Okay, and now simply you have to remember the symbol for that. Okay, simple. See, these are the symbols. And the one more point is, okay, one more point is, for this form geometrical tolerances, for this, there is no requirement of the datum. No requirement of the, no datum line is required. Okay, no datum is required. What is meant by the datum? Yes, what is meant by the datum?
Reference plane.
Yes, the datum is nothing but it is the reference point. It is the reference point, it is the reference line, it is the reference axis, it is the reference plane. Means म्हणजे समजा मला काय चेक करायचं आहे, फॉर एक्झाम्पल say like this. Suppose this is the A and this is the B. Okay. This is the B. It is perpendicular. म्हणजे हा A जे सरफेस आहे तो B ला परपेंडिक्युलर आहे. B ला परपेंडिक्युलर आहे. म्हणजे काय मला कोणत्याचा तर रेफरन्स द्यायचा. म्हणजे समजा A हे डिस्टन्स, सॉरी A आणि B मधलं डिस्टन्स किती आहे? 5 mm आहे. A पासून B चं डिस्टन्स किती आहे? 5 mm आहे. मी कशाचा रेफरन्स दिला? A चा रेफरन्स दिला. It is called as a datum. Datum is nothing but it is the reference point, reference line or reference axis. Okay. म्हणजे आपल्याला हे चार कॅटेगरी दाखवण्यासाठी रेफरन्सची गरज लागणार आहे का? इट इज द इंडिव्हिज्युअल फीचर्स. येस, समजतंय का?
Yes, sir.
Okay, you have to remember to show the straightness, flatness and the circularity. It is not required the datum line. Okay, then see here how to read it. आता बघा हे आपल्याला कसं दिलं जातं. For example, suppose they have given like this. Okay, then tell me what is the meaning of this? In this box, they will given like this. Tell me what is the meaning of this? It is called as the control feature. It is called as the control feature. Then tell me what is the meaning of this?
The shaft having thickness within 0.101
Yes.
mm.
Yes, please repeat.
The shaft having thickness within 0.01 mm.
Means suppose this is the one shaft and the straightness of this shaft, the straightness of that shaft should be within 0.01 mm or micron. Okay, म्हणजे ह्या शाफ्टची स्ट्रेटनेस तुम्हाला किती पाहिजे? जर हे प्लस मायनस मध्ये गेले तर किती व्हायला पाहिजे? लाईक दिस, within 0.1. Okay, if suppose they have given like this. Then tell me. What is meaning of this? Yes. What is meaning of this?
Circularity of shaft should be within 1.00
Okay,
mm.
within 1.00 म्हणजे जी सर्क्युलेटी जर आपण तुम्ही चेक केली तर त्याचा टॉलरन्स किती पाहिजे 1 mm मध्ये किंवा 1 मायक्रॉन मध्ये त्याची सर्क्युलेटी आली पाहिजे. ओके, अंडरस्टूड. सपोज
Flatness of shaft should be within 2 mm or micron.
2 mm. Okay, and one more point is there. Okay, for this straightness, flatness and cylindricity and circularity, no requirement of datum. Datum is not required. So understood? Datum is not required. So understood?
Yes, sir.
So we'll take the next geometrical tolerance. Okay, location. Okay, so how many characteristics are there for the location? Again, it having the 3 characteristics are there in that location. The first is the position. Then second is the concentricity. Okay, and the third is the symmetricity. Okay, symmetry. Okay. So first up, we will discuss here what is meant by the position, what is meant by the concentricity, and the symmetricity. Yes. Then what is meant by the position? Yes. What is meant by the position? Again, the one more point is, okay, for this geometrical tolerances, we have to require the datum. Datum is required. Right? Okay, you have to remember the datum is required here. म्हणजे काय रेफरन्स पॉइंट आपल्याला लागणार आहे ह्याच्यामध्ये. Datum is required. Okay. Then what is meant by the position? When we can call position, concentricity, and symmetricity? Yes. Yes, anybody? Yes. Means, for example, position means it is showing the exact position. For example, suppose this is the one plate is there, and on that plate, suppose we have to produce one hole. Here. Okay. Okay, that hole is there. Suppose this hole from this point, it should be on the distance 20 mm, and from this pointer again up to this, it will be the 10 mm. Okay, 10 mm. Okay, and if they have given like this, okay, so this is called as the datum. Datum is showing on the inverted triangle. Okay, so this is the datum. Datum is always showing on the inverted triangle like this. Suppose this is the A datum, and suppose this is the B datum. Okay. And suppose they have given like this. So this is the symbol for the position. Okay, this is the symbol for the position. 0.01 A and B. A and B. Okay. Then tell me, what is the meaning of this? What is the meaning of this? Position means what? This hole. Okay, see, this is the circle. Okay, this is the circle. This is the circle. And what is meant by the position? म्हणजे बघा ह्याच्यामध्ये हे जे सर्कल आहे तुमचं, हे जे सर्कल आहे, जर चुकून समजा इथे ड्रिल झालं, okay, suppose this circle is going to drill here. Again, is it acceptable? Yes. हित होण्याच्या ऐवजी ह्या ठिकाणी झालेलं आहे. आणि सपोज दिस डिस्टन्स इट विल बी विथ इन टॉलरन्स. जर हे डिस्टन्स तुमचं 0.1 mm मध्ये असेल तर हे ऍक्सेप्टेबल आहे का? येस. 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 हॅलो.
तर ते पोझिशनचं सिम्बॉल डबल सर्कल नाही आहे.
Yes. Sir. It will be like this. Good. Okay. It should be like this. तर समजते का? What is meant by the position? Position चा अर्थ समजला का तुम्हाला? Position म्हणजे काय?
हा सर.
म्हणजे समजा फॉर एक्झाम्पल जर असं असेल तुमचं, ओके, हे इथे एक सर्कल घ्यायचं आहे, हे डिस्टन्स असेल, इथे असेल 10 असेल आणि डिस्टन्स 10 असेल, म्हणजे तुमचा सर्कल कुठं ड्रिल व्हायला पाहिजे? इथं व्हायला पाहिजे. पण काय झाला, सर्कल आपला ह्या ठिकाणी ड्रिल झाला. ओके, ह्या ठिकाणी ड्रिल झाला लाईक दिस. ओके, बट हे जे आहे ते कसं आहे? विथ इन टॉलरन्स आहे. त्यांनी जर आपल्याला असं दिलं असतं, असं दिलं असतं, पोझिशन should be 0.01. ओके, विथ रिस्पेक्ट टू एनी डेटा, विथ रिस्पेक्ट टू एनी. म्हणजे याचा अर्थ काय झाला? हे जे होल आहे ते 0.1 mm टॉलरन्स मध्ये जर तुम्ही ह्या साईडला जर कुठं जर सरकलं, अगेन इट इज एक्सेप्टेबल. इट इज कॉल्ड ॲज द पोझिशन. अंडरस्टूड? Yes. Position means what? Understood or not?
Okay.
Okay. Then what is meant by the concentricity? Yes. When we can call it is the concentricity. Yes. Now here, what is the symbol for the position? The symbol for the position, it will be like this. This is the symbol. Okay. Then what is meant by the concentricity? Yes. What is meant by the concentricity when we can call it is the concentricity?
Exact value.
Yes.
Only one center for two parts or objects.
Okay, good. It is correct. Means suppose we are having one cylinder. For example, I will draw here. Suppose this is the one cylinder is there. Suppose this is the circle, okay, and suppose this is the circle. So this is the center point for this. Again, this is the center point. Okay, means see, this is the circle 1. We can call this is the circle 2, for example. Okay, the center point of the both the circle. Yep, the center point of the both the circle should be in line. म्हणजे ह्याचा सेंटर पॉइंट आणि ह्याचा सेंटर पॉइंट सेम याच्यावर असेल, सेम असेल, इक्वली असेल. ओके, तर वी कॅन कॉल इट इज द concentricity. It is correct? Yes or no?
Yes, sir.
Okay. Okay. आणि समजा आपल्याला असं दिलं असेल तर त्याने what is the symbol for the concentricity? The symbol for the concentricity, it will be like this. It is correct symbol? Yes.
Yes, sir.
Okay, if they have given like this. What is the meaning of this? What is the meaning of this? Yes.
The cylinder having concentricity within 0.2 mm.
Okay. With data. With data means suppose they will give like this also. A, B, C like this. Data. Here we can write the data also. Okay, say this is the concentricity. Okay, this is the concentricity. This is the concentricity. Concentricity means the center point of both the axes should be equal. Okay, बरोबर आहे. म्हणजे जर हा ऍक्सिस 2 mm चा थोडा इकडे सरकला, असाच राहिला, again it is acceptable because it is within tolerance. It is in limits. It is called as the concentricity. Okay, and what is meant by the symmetricity? Yes, what is meant by the symmetricity? See, this is the symbol for the concentricity. This is the symbol for the position. And what is meant by the symmetricity? Symmetricity means what? Yes. Yes. For example, suppose we are having one component like this. Suppose this is,
Symmetry आपण नॉन सर्क्युलर फीचर साठी अप्लाय करतो.
yes.
नॉन सर्क्युलर
Okay. Now see here the symmetricity. Suppose this is the one component here like this. Okay. When suppose this is the component. See, if this distance and this distance, if it is equal, then we can call it is symmetrical. No? Suppose this is 2 mm, this is 2 mm. If from this line, this distance, and from this line, distance, both are equal, then we can call this component is the symmetrical. It is correct. Yes or no?
Yes, sir.
And how to show the symmetricity? Okay, the symbol for the symmetricity, it will be like this. This is the symbol for the symmetricity. Okay, so understood what is meant by the position, what is meant by the concentricity, what is meant by the symmetricity, and these are the symbol. And the important point is for the location we have to require the datum. Reference point हे लागणार आहे दर्शवण्यासाठी. Okay, the reference point is required here. Okay, reference point is required here. So understood? Yes.
Yes, sir.
Okay. The next types of the tolerance is run out. Okay, run out. Run out. Run out. Okay, it having the two characteristics. Okay, and the first is the circular run out. First is the circular run out, and second is the total run out. Total run out. Total run out. And what is meant by the circular run out and total run out? Yes. Then tell me what is meant by the run out in Marathi we can call. What is meant by the run out? Run out म्हणजे काय?
जास्त प्रमाणात
म्हणजे काय एक्झॅक्ट?
म्हणजे जेवढं पाहिजे त्यापेक्षा जास्त.
Sort. Suppose this is the shaft. Suppose this is the shaft. Okay. And suppose we have hold that shaft into the check. Okay, in that lathe machine and we have rotate. Okay, if we have rotate this shaft. Okay, and you have to check the run out. म्हणजे थोडासा टग घालतो बघा आपल्या मराठी भाषेत तो टग आहे. राईट? Yes or wrong? Yes. It is called as a run out in our simple language. Okay, then what is meant by the circular run out and what is meant by the total run out? Okay, just see. Okay, just see. Suppose this is the one rod is there. So this is the rod. Okay. Suppose we have rotate this rod at 3 degrees system. मी रॉड काय केला रोटेट केला किती 360 डिग्री आणि ह्याच्यावर काय केलं मी एक पॉइंट मी फिक्स केला आणि ह्याचं काय केलं डायल गेजने मी ह्याचं रोटेशन चेक केलं. ओके, म्हणजे काय करायचं आहे म्हणजे मला सांगा इथून जर मी एक पॉइंट फिक्स केला आणि चेक केल्यानंतर पूर्ण या शाफ्ट काय केलं मी रोटेट केलाय आणि चेक केलं डायल गेज त्याचं व्हेरिएशन किती येते अपडाऊन पणा किती येतो अपडाऊन पणा. You have to imagine. Suppose this is the shaft and we have rotated this shaft. Okay, we have rotated this shaft and we have checked the rotation of that shaft. Okay, at one fixed point. How much it is deflected? How much it is deflected? How much it is moving up and down like this? How much it is moving up and down? Okay, that variation is called as the circular run out. And suppose we have checked this shaft throughout this length. At this pointer, this pointer, this pointer, this pointer, or this pointer, and this pointer. Okay, we have to check. Then it is called as the total run out. म्हणजे हा शाफ्ट आहे, हा शाफ्ट मी रोटेट केला आणि एका पॉइंटला मी व्हेरिएशन चेक केलं. अप डाऊन किती येतो तो अप डाऊन. ओके, दॅट व्हेरिएशन इज कॉल्ड एज सर्क्युलर रन आउट. आणि हा शाफ्ट जर मी थ्रूआउट चेक केला प्रत्येक पॉइंटला आणि त्याचं मॅक्झिमम आणि मिनिमम जर व्हेरिएशन काढलं तर इट इज कॉल्ड एज द टोटल रन आउट. बरोबर आहे का? Understood? It is called as a run out. Yes or no?
हाँ सर.
Okay. Then see here how to represent it by the symbolical. The circular run out, it is indicated by this symbol. It is indicated by this symbol, and the total run out, it is indicated like this. Okay, so understood? Yes or no? समझते का नहीं?
Yes, sir.
हाँ सर.
Remaining student Raut.
Yes, sir.
Yes, sir.
Okay, so this is the run out. Here for this run out, the datum is optional. The datum is optional. Sometimes it is required, sometimes it is not required. Datum line is optional. Okay, reference काय गरज असू शकते नसू शकते. Okay, so next part, that is the profile. Okay, third, fourth profile. Okay, profile geometrical tolerance. Profile again, it having two types. First is the profile of line. Okay, profile of the line. Profile of the line, and the second is the profile of the surface. Profile of the line and profile of the surface. Then what is meant by the profile of the line and what is meant by the profile of the surface? Yes, anybody? Yes. For example, suppose this is the notebook. It is visible to all? Yes. See, this is the profile of this notebook. This is the profile. It is called as the profile. It is called as the surface profile. Surface profile. And if we take a line profile, see, it is called as the line of profile. Means, for example, take the example of the mobile. See, what is the surface profile of this mobile? See, this is the surface profile. This whole surface we are showing, it is called as the surface profile. Kasa hai surface profile mobile sir? Yes. How it is looking? The surface profile of the mobile, it will be like this. It is called as the surface of the profile. Okay, and it is called as the surface of the profile. And what is meant by the line of profile? The line of profile म्हणजे मी एकाच लाईनचं प्रोफाइल काढली. कसं दिसेल रे? How it is looking? Like this. See, it is curve. Okay, radius, straightness, radius. It is called as the profile of the line. Understood? It is called as the profile of the line, and it is the profile of the surface. Yes. Understood? What is meant by the profile of the line and what is meant by the profile of the surface? Yes or no?
Yes, sir.
Okay, now how it is showing? What is the symbol for the profile of the line? The profile of the line is showing this symbol, and the profile of the surface, it will be showing like this. It should be closed like this. It should be open, it should be closed. This is the profile of the line. Okay. Here, datum is optional. Datum is not required. Datum is the optional. Yes, understood? Yes. And then last.
Profile of line चा symbol जरा काढा double.
The symbol for the profile of line, it should be like this. Now just this up like this. Now it is visible.
Yes, sir. Understood, sir.
So the last is the orientation. Last is the orientation. Okay, means here orientation means what? Angle. Orientations. Which features are there here? Here, perpendicularity. Perpendicularity. Then second is the parallelism. Okay, and third is the angular. Okay, here again we have to require the datum. datum is required. Reference point लागणार आहे. Okay. Then what is meant by the perpendicularity? Yes.
That's 90 degrees to the datum plane.
Okay, means two surfaces, they should be at a 90 degree. Then what is meant by the parallelism? Then we can call parallel. Suppose this surface and this surface both are parallel to each other. Means what? They are not cutting to each other. Okay, and angular means at a particular angle, like this. Okay, just I will write down here the example so that you will understood. Okay. Means what? Okay. Suppose sometime they will give like this. Okay, they have given the example like this. What is this? What is this? What is this? A is indicate
Datum.
datum. Here you can write down A, B, C, D, any letter you can write down. And you have to remember this is the symbol for the datum in a vertical triangle. Okay, and that triangle should be filled. Okay, and suppose they have given like this. Tell me meaning of that. Tell me meaning of that. Zero 0.02 mm. And suppose then tell me meaning of this. Yes, what is the meaning of this? This surface, see, this surface should be perpendicular with reference to this point, with reference to this surface within the tolerance of 0.02. म्हणजे हा जी लाईन आहे किंवा हा जी कंपोनंट आहे ह्या कंपोनंटला बी ला सॉरी ए ला किती परपेंडिक्युलर पाहिजे आपल्याला, किती टॉलरन्स मध्ये पाहिजे, 0.2. ओके, अंडरस्टूड?
Yes, sir.
Yes, sir.
Then suppose next example. See, this is the symbol for the perpendicularity. This is the symbol for the perpendicularity. And suppose they have given like this. Okay, suppose this is the datum. Okay, suppose it will be the D. Yes, tell me. Yes, tell me. What is the meaning of this?
First surface parallel to second surface within tolerance 0.01.
Is this surface should be
Shaft having
this?
parallelism with tolerance zone 0.01 mm to the datum plane B.
Good, good. It is good. Okay. See, this is the parallelism. The parallelism of this surface, okay, within 0.01 mm tolerance with respect to datum B. ह्याला रेफरन्स हा रेफरन्स पॉइंट धरून आपण हा रेफरन्स पॉइंट धरलेला आहे आणि ह्याला किती पॅरलल पाहिजे, विथिन दिस टॉलरन्स पाहिजे. ओके, जर ह्याच्यामध्ये असेल तर वी कॅन से इट इज एक्सेप्टेबल. ओके, सो अंडरस्टूड. Okay, and the parallelism, it is showing symbol like this. Okay, then angularity like this. Okay, again here datum is required. C or A we can write out. Then tell me. This is symbol for the angularity 0.01 with respect to you. Huh? Yes.
The angularity of the plane having tolerance zone 0.01 mm to the datum plane A.
Datum plane with this. Okay, like this. And here you can see this orientation feature. We have to require the datums. We have required the datums. Okay, these are the geometrical tolerances. Okay, so these are the 14 symbols are there. So first of all, we will write down that all the symbols. Okay. Okay, so before that we will see here feature control frame. Okay, feature control frame. Feature control means already we have discussed here. Feature control frame means how they will give the all the dimensions, all the tolerance, all the symbols like this in the one boxer. They will first upon in that first boxer there will be the tolerance symbols. Okay, it will be the perpendicularism, parallelism like this. In second boxer they will give the they will give the tolerance, and in the third it will give the datum A, B, C. Okay, three types of the datums are there. Okay, in that first box they will give the geometrical characteristics. Okay, geometrical characteristics or symbols they will give. Then here they will give the tolerance zone. Tolerance values are there. Here they will give the, it is called as the primary datum. It is the primary datum. It is the secondary datum, and it is the tertiary datum. Okay, in this format they will ask. Okay, that format you have to remember. Means काय असणार आहे असं दिलं असेल तर yes, tell me if they have given like this. If they have given like this. Tell me what is the how we can read it.
Circularity of shaft should be tolerance zone within 0.2 mm.
With respect to datum A, B, C. Okay. This is called as the feature control. Okay. So first of all, we'll write down the symbol. Serial. And types of the tolerance. Okay, then yes, types of the tolerance, then characteristics. Characteristics, then here symbols, and datum is required or not. Please first tell me. Here I will write down serial number. Okay, here types of the tolerance. Types of tolerance. Then here I'll write down characteristics. Here I will write down symbol. Here datum is required or not. What is the first term? First term of the tolerance is the
Form.
Okay. Again, that form, how many characteristics are there? First is the straightness. Okay, straightness. Then second,
Flatness.
okay, flatness. Third,
Circularity.
circularity. And fourth is the
Cylindricity.
okay, cylindricity. What is the symbol for the straightness? Yes.
Straight.
Okay, just we have to write down straight line, flatness, like this symbol is there. Circularity, circular is there, and cylindricity, like this. Okay. So this is the first type. Tell me, datum is required here.
No datum plan is required.
Okay. Here datum is not required. Okay, datum is not required. No datum is required. It is individual feature. No datum म्हणजे आपल्याला हे दर्शवण्यासाठी रेफरन्स पॉइंटची गरज नाही. No datum is required. Okay, then next yes.
Location.
Okay, location. Next is the location. How many characteristics are there?
3.
Okay, location. Here 3 is there, here 4 is there. What are that 3 characteristics are there in the location?
Position.
Yes, position. Then
Concentricity.
symmetricity
Symmetricity.
and symmetricity. So what is the symbol for the position? The symbol for the position, it will like this. Symbol for the concentricity, it will be like this. And symbol for the symmetricity, it will be like this. Okay. Here datum is required. Yes. Datum is required here. Datum required. Okay. Then next yes.
Run out.
Okay. Run out. Third number is the run out. Okay. Third is the run out. Third is the run out. Here again, 2 types are there. Yes.
Circular run out.
Okay. Circular run out and total run out. Means within one point we have check and total run out throughout the shaft. Total run out. Okay. Here, what is the symbol? Just we have to draw this like this arrow, and here like this. Okay. Like this arrow. Here datum is required. Required. Then next
Profile.
Profile control.
profile control. Next is the profile. Okay, profile. Again, it having how many characteristics are there? 2. Okay. The first is the
Profile of line.
okay profile of
Surface control.
Line.
profile of line and the profile of the
Surface.
surfaces. Here, profile of the line and profile of the surface should be closed. Okay, like this symbol. And here datum is the optional. Okay, sometimes it is required, sometimes it is not required. Optional. Okay. And what is the last?
Orientation.
Okay, orientation. In that orientation, how many are there?
3.
Okay, 3. First is the perpendicularity, then parallelism, and third is the angularity. Okay, directly I will write down this symbol here: perpendicularity, parallelism, and the angularity. Here datum is
Required.
Okay, these are the geometrical tolerances are there. Okay, so this is the symbol. This is the symbol for that, and for this symbol, okay, in that control frame, we will first up on in that control frame box. In first box, we will give the symbol like this. Okay, then we will give the tolerance. Okay, and third we will give the datums. Okay, the meaning of that is suppose it is the flatness. Okay, the flatness of that surface should be within this tolerance with this datum. Okay, in the datum. म्हणजे तुम्ही एखादा कंपोनंट जर मॅन्युफॅक्चरिंग करायला लागला तर ट्रेटनेस मी इथे दाखवली अशी ओके हे कंट्रोल फीचर मध्ये तर ह्याचा अर्थ काय असणार आहे ही ट्रेटनेस तुमची 0.1 च्या टॉलरन्स झोन मध्ये असेल तर आपण ऍक्सेप्ट करूया ओके जर मी एखादा शाफ्ट मॅन्युफॅक्चरिंग करत असेल या ठिकाणी ओके आणि आपण मी ह्याला असं दाखवलं ओके, ह्या शाफ्टची सर्क्युलरिटी 1 mm असेल, 1 मायक्रॉन दिली असेल तर म्हणजे काय होणार आहे, जर तुम्ही ह्या शाफ्टचं जे काय सर्क्युलरिटी असणार आहे, ओके, जर थोडीफार व्हॅरी झाली, किती व्हॅरी व्हायला पाहिजे या ठिकाणी, किती टॉलरन्स दिला आहे सर्क्युलरिटीला आपण 1 mm मध्ये जर तुमचं जर हे सर्कल मॅन्युफॅक्चरिंग झालं तर इट इज एक्सेप्टेबल. येते, अंडरस्टूड? द मीनिंग ऑफ दॅट इज लाईक दिस. येस ऑर नो? येस, it is called as the geometrical tolerances. So understood?
Yes, sir.
Yes, sir.
So any doubt, any problem, please tell me regarding to this. Yes?
No, sir.
Okay. So thank you. Okay, we have covered the dimension tolerance, the geometrical tolerance, and surface roughness symbols also. So it is necessary to take once again surface roughness symbol. Yes. Okay. So anybody having any doubt, any problem regarding to this? Yes.
No, sir.
Raut, it is clear na?
Yes, sir.
Police Patil. Nakate is here, Nakate.
Sir.
Asaur, it is clear?
Sir. Can I ask you one question?
Yes, yes, wait up 2 minutes.
Why we use geometric dimension and tolerance in engineering drawing?
Yes? Yes, please.
Why we use geometric dimension and tolerance in engineering drawing? How we
Okay.
answer of this question?
Yes, that geometrical tolerances we are using in the engineering drawing because already I have explained it is the graphical representation, and to show the times and to show the suppose if you are not giving the geometrical tolerances, okay, then again we will become the confused. Okay, how much flatness is required, how much straightness is required, how much circularity is required, how much tolerances are there. Okay, during the design that design engineer will develop these tolerances. Okay, during the designing there it will be develop this tolerance and they give the that geometrical tolerance, and because of that geometrical tolerances our work is going to minimize na. Again काय होईल ह्याच्यामध्ये आपल्याला the rejection it will be minimized. The rejection it will be minimized na. If you are not giving the tolerances, then every time it is possible to manufacture exact straightness, exact circularity, it is possible.
No, sir.
Then how we will define it? Okay, for this purpose we have developed the geometrical tolerances. With the help of that geometrical tolerances we can easily understood if suppose we have to manufacture these surfaces. Okay, suppose we have to manufacture this component, and during the manufacturing that component, if our straightness is vary, okay, if your straightness or your flatness or your circularity is vary, but that variation should be in proper tolerance zone. And what is the symbol for that? We have to develop the symbol. Okay, every time we can write here the tolerance on the flatness is required within 0.02. No, okay, for this purpose we have developed this symbols here. Just we have to give the symbol and give the tolerance, so that automatically we can easily understood. Okay, this component we have to manufacturing, during the manufacturing of that component we have to follow this point only. It means the surface flatness, the straightness, the circularity of that component should be within this tolerance only. At tolerance zone मध्ये आलं तर आपलं हे acceptable आहे. Okay, for this purpose we are using the geometrical tolerances. So understood?
Yes, sir. Thank you.
So remaining, yes.